So let us see how we're going to try and write code for this function. So we want to focus only on lowercase vowels, and we want to count repeated lowercase vowels separately. How are we going to do this? So as an inspiration, let's go back to the earlier code that we had, even though this had a small bug with negative numbers. But we will try and follow a similar logic. So here we had a base case to handle very small numbers. And then when numbers were very large, we did floor division by 10. And then whatever that answer was, we calculated how many digits that had, and then we added 1 to it. So as a reminder, for 234, floor division by 2 will give us 23, and so the number of digits in 234 is 1 plus the number of digits in 23. And what is the number of digits in 23? Well, that is 1 plus the number of digits in 2. We want to do something similar with vowels. So once again, let's think of a concrete example. Let's say we're calculating the number of vowels in cat. Well, we have to break this up into a smaller string, a substring. So how about, for example, we say, well, it is 0 plus the number of vowels in at. Why 0? Because C is not a vowel. So it's not going to be exactly the same as this, but in this case, because C is not a vowel, we will say 0 plus the number of vowels in at. And at we can calculate from cat by just simply slicing it, starting at index 1 up to the end of the string. Now, how many vowels are there in at? Well, that is 1 plus the number of vowels in the rest of the string, the slice. So that's because little a is a lowercase vowel. So instead of blindly adding 1, we will sometimes have to add 0 and sometimes we will have to add 1. So we'll have to write our code a little bit carefully. And then we can make use of the slicing idea when we recursively call the function. So let's try and implement this code, but wait, before we had a chance, our friend has already attempted this. Let's take a look at what our friend wrote. Here's our friend's code. They have added one more doc test about India returning 2 because we don't care about the uppercase vowels. We only are focusing on the lowercase vowels, and there are 2 lowercase vowels here. So how does our friend's code work? Well, our friend has used this if-else expression that we saw in an earlier lecture. How does it work? Well, we first check if S0, the 0th letter, that is to say the first letter in the string, is in this string. This string contains all the lowercase vowels. So if this happens, then first vowel is initialized to 1, otherwise it's initialized to 0. So at the end of this line, first vowel will either be 1 or 0, depending on whether the first letter is a lowercase vowel or not. Now, if the length of the string is 1, this is our base case, just return this variable. That is to say, return either 1 or 0 depending on if the first letter is a vowel. If we come to this line, it means the string is not of length 1. It's not the base case. In that case, we're going to return whatever this first vowel was, 1 or 0, plus recursively on the slice of the string starting at index 1. Our friend seems to have captured all the ideas that we discussed in the example below. But is this code correct? Don't just blindly trust it because it looks right. Don't trust it because it has all the features that you were expecting in terms of the syntax of the code. Please check the code carefully using this link.